Okay, we are now beginning a new chapter. You can, I can say, this is like we finished right now a major section, and now we're beginning perek Zayin, chapter 16. And right now, it's good for you to, everything we said about the moon, about all the different cycles, to just somehow try to get everything into a simple circle with the center Earth and the moon surrounding it. In other words, even though there's all kinds of things happening, but essentially it's really what the point is, that there is a certain point that goes around Earth. That's where we see the moon. It's just different things cause it to be, sometimes to go fast, sometimes to go slow, and that's why we have all these cycles. But just imagine there's a point going around another point, that's the moon going around Earth. Now, so just to try, for simplicity's sake, for your own good, just to have now a simple circle, the moon going around. However, here comes a major kiddush, a major point we did not discuss yet. This plane, we'll show a picture soon, is not the same plane as the sun. So I'll give you right now a diagram to understand what we're talking here. Let's go to this diagram here. Okay. So let me go a different picture first. Okay, this is the best picture. So we have the Earth in the center, we have a celestial sphere, and this is you can see this is the sun. The sun goes here. The moon, however, does not travel on the same plane as the sun. It's tilted 5 degrees. So it's always, it's either that the sun is on the same plane of the ecliptic, means the galgal amazalis. So we can make like a straight, how do you say, a flat, huge surface where you can place the Earth, the sun, and the galgal amazalis. Imagine you have a tabletop. You have the Earth in the middle of the table. Then around the table you have the sun. Then you have another table, or actually the table is extremely, extremely wide. And then there's the stars. So they're all on the same plane. The moon, however, is sometimes above the table and sometimes below the table. It's not on the same plane. So during the month, as I said, try to forget about now all these details. Just imagine the moon goes around the Earth. Because it's not worth now to think about all these galgalim. Just imagine there's a simple moon traveling. So up to now we understood it's on the same plane. It's like on the table. We have the center of the Earth. Then we have a circle, the moon. That's like one circle on the table. Then on the rim of the table, the sun. Then imagine the table gets even wider and wider. Flat table, you have the sun. But this is not the case, because we'll see that the moon is underneath the flat table. I'm having in front of me here a glass round table, so I'm using this for imagination. I hope you understand. It's a round table. So either you have the moon above the table, half of the month, and then it's called ascending node, because you go above the plane of the ecliptic, means the plane of the mazalas, and then he reaches the highest point is 5 degrees above the ecliptic plane. Then another half of the month he is below the ecliptic plane. Let me see if I have another picture here. Oh, this is also a picture. It tries to show that there is this orange, this purple thing. This is where the moon goes. It's either below this plane or above the plane. This plane here, this big plane is the plane where the sun and the stars are. The moon is not on the same plane. Same thing. This is also showing the 5 degrees. The moon's orbit is not on the ecliptic. The sun goes on the ecliptic plane. That means the same plane of the stars. This is above. So let's see the Rambam inside, and hopefully, together with the diagrams and with the Rambam, understand better what's happening here. So zog the Rambam. Ha'agula shesoiv b'yirech tamed inoita me'al ha'agula shesoiv b'Hashem tamed. The agula, the circle that the moon circles, is tilted from the circle that the shemesh. Chetzi noita l'tzof, chetzi noita l'dar. There is half of the plane is towards is north of the ecliptic and half is south, as we showed in the picture. Kiddush yesh bar zu keneged zu. And then there's 2 dots. So we saw that there are 2 places, 2 times, where we can see that actually it touches the ecliptic plane. Let's just go back to this picture. It's very clear. At this point and at this point. See this line? So 2 times during the month when the moon is on the ecliptic. It's the same plane of the sun. Once it goes out from these 2 points into Malchus, it's either north of the ecliptic plane or south of the ecliptic plane. So that point we'll call the rosh, the head. It's the tail. Because from that point to further, it goes down, it docks down beneath the ecliptic plane. So the question is, obviously, we can ask at which point, where is this located? Where does it start docking up and docking down? Where, on which mazel, which degrees of the ecliptic does this happen? The answer is, as usual, it depends. Depends where, what time of year, where are you asking? When? The Rambam's time, today's time, so it keeps on changing. But there is, however, in every time, in every generation, or in every year, there is a certain point where it's called rosh and vezanav. Rosh is the point where the moon, at that degree, he goes up above the ecliptic, and vezanav is that point of the ecliptic. Obviously, it's 180 degrees later, where he goes beneath. And this point, what we call rosh, keeps on fluctuating. Interesting thing, however, is that all these things that Gadmonim figured out from observation, obviously, they saw that the point of rosh goes backwards. So let's say in the Rambam's times, let's say it was by 5 degrees of Tuleh, so that was the rosh point. Obviously, the vezanav was 5 degrees at Meznaim, right? It's 180 degrees later. But we're focusing right now on the rosh. So let's say the Rambam's times, the rosh was 5 degrees of Tuleh. However, you passed another 100 years or so, it was 4 degrees of Tuleh, 3 degrees. As interesting as it sounds, that point, Hashem made such a way it should go backwards on the ecliptic, and we always have to figure out where that is, so we have to work in a little bit interesting way. We'll see soon. The Rambam gives us a method. You have to work backwards. So let's see some details first. Each day it goes very, very slow. Only 3 chalakim. That's a 20th of a degree. 20th. 31 chalakim. So in 100 days it goes 5 degrees. Actually, not so slow. 100 days it's already 5 degrees backwards. So now it gives us all the numbers. And obviously, we know the rule that if it's more than 360, we just drop it. So this is the way the Rambam gives us 10,000 days. He gives us 169 miles. Kif samach tes. Then some hachal tisha b'esrim yoyim. Mila achas 1.5 degrees about. 29 days. The rosh travels backwards 1.5 degrees. So if you know where the rosh is on a certain given date, you want to know where the rosh will be in 29 days. You just have to deduct from that. Remember, deduct. So let's say you know that the rosh is right now, as we're talking, it's on 35 degrees of the ecliptic. So we know that in 29 days from now, it will be 33.5. It goes 1.5 degrees backwards. Okay. So now it says Shana Sedura, it goes 18 degrees and 44 halakim. And okay, Simon Yudches Mamdalat based, so it's like 18 and 2/3 degrees again, or everything is here goes backwards. Ve'emtza harosh b'tchilas leil chamishi shehua iker. The Rambam always has his famous Thursday night where everything starts from there. Hoya meya shmoina miles. Shiva v'chamishim chalakim, Ishmayne b'esem shniyas, Simanam kuf pei nun zayin chof ches. So the Rambam gives us, he says, as we are on his days, where the rosh was. But so this is what the Rambam says. So let's see. Rambam gives us for future. If you want to know in any given time, Toitziam Tsoy Loisa Eis Kiddush Toitzi Emsa Shemesh Emsa Yereich. V'tigra Emsa Mishloish Meyos V'shishim Mailos. You should deduct it. You should finally, when you have the answer, you should take Tigra Emsa Mishloish Meyos V'shishim Mailos. So I want to explain what the Rambam means here. It should be confused. So the Rambam is doing here a shtickle trick. It's not so. It's a convenient trick. When the Rambam says here that in his days the rosh was kuf pei, it's not the rosh. It's called the emtza rosh. So really, it was. The Rambam says 180 nun zayin. So really it was 360 minus. Let's say, you know what, for convenience, let's say the Rambam would say here 181. It's very close to 181. So really in the Rambam's time, the rosh was 179. So the Rambam said, I'll give you the number in a 360 minus that. That's 181. Instead of saying the truth. The truth is, in the Rambam's days, it was 179. But it's easier to do this way. That what we give here the number that's 360 minus that. So it's 181. And then you keep on adding instead of subtracting. It's easier to add and subtract. You keep on adding, and the final number, you subtract that number from 360. That makes you get the same result as of subtracting. I'll explain that here with a very practical example to get the concept correct. Let's assume that every day, to make things very simple, that every day it goes 1 degree. So let's say 5 days have passed from the Rambam's day. So how do we do it? We say 181 plus 5 is 186. Then we do 360 minus 186, that's 174. That's the same result as of going 179 minus 5. So it's a mathematical trick. You can figure it out. This is how we work. We take the opposite. Instead of taking the 179, we take 181. We add instead of subtracting. And finally, we subtract the result from 360, and we get the